Hello and welcome to our STEAM projects based on the Raspberry Pi Pico and MicroPython. These lessons are designed for the somewhat experienced STEAM teacher. We call this second level the SHERPA level. In our project number 4, we are going to program a sound sensor to switch on and off a DC motor. My name is Peter. I am the founder of Educomondo and a certified STEM instructor and course developer. The goal of today is to switch on and off an electric motor by making a clapping sound. We will introduce a new component, the TIP122, which is a transistor to drive the DC motor. We will introduce the sound sensor. You will learn how to integrate all of these components into a project that controls the switching on and off of the DC motor using sound. And we will make sure that your class is working as a team and optimizes their solution skills. Let's take a closer look at the sound sensor. In the Key Studio Starter Kit, this sensor is nicely integrated into a small circuit, including a pot meter to select its sensitivity. A sound sensor is a device that can detect sound waves traveling through the air and convert them into electrical signals. There are 3 pins: the volt pin, the ground pin, and the analog signal pin. On this printed circuit, there is also this small amplifier on a chip, the LM386. The TIP122 is a device that can control the flow of current in a circuit. It is made up of 2 smaller transistors connected together, which makes it a Darlington pair transistor, named after Sidney Darlington, who invented this in the 1950s. This configuration allows the TIP122 to have a very high current gain, which means that it can amplify a small current into a much larger one. And although in most starter kits the DC motor is controlled by a more modern chipset, the L293D, which we saw in the Arduino lessons, it may be useful to understand a bit better the working of this old electronic component that, after all, helped to shape today's modern digital world. To install the TIP122 correctly, we need to know what the function of the 3 pins is. A transistor has 2 functions: to turn something on or off and to amplify a weaker signal. It consists of 3 pins: the emitter, the collector, and the base. The current comes out of the emitter and is usually connected to the ground. The base governs the on and off, and that is why we connect it to the digital pin of the microcontroller. The collector is where the load, in our case the DC motor, is connected. When a voltage is applied to the base, setting a digital pin to 1 or high, it allows current to flow from the emitter to the collector, turning the transistor on. When the voltage to the base is removed, the transistor turns off. Because of its amplification characteristics, the TIP122 is used when you need to control higher power consuming loads or to intensify a higher current. That's it for the theory. Let's start building the project. We will need the following components: the large breadboard with the Pico installed and the pinout reference card, the sound sensor, the TIP122, a resistor of 1000 ohm, the DC motor, a 9-volt battery and the external power supply. And of course the fan to keep us cool. We will also need a box of preformed wires and a bundle of jumper cables. Tell your students that they need to build 2 circuits. The input circuit is the sound sensor, the output circuit is the TIP122 and the DC motor. The input circuit serves to read the analog value reading from the signal pin of the sensor. We connect the positive pin to 5 volt of the Pico and the negative to the ground. The signal pin is connected to pin ADC0 or pin 26. This GPIO 26 is easy to remember because it is the 10th pin counting from the top right side. In the output circuit, we connect the TIP122 with the base to GPIO 15. This one is also easy to remember as it is the left bottom pin. The emitter is linked to the ground. The collector is linked to the negative lead of the DC motor. And while we are at the DC motor, we connect the positive lead of the motor to the positive rail of the breadboard. Now we add the external power supply. Very important is to ensure that the Pico and the power supply share the same ground. Note that some breadboards are divided in 2 separate parts, so make sure that you link the ground the correct way or the project will simply not work. Now we can start with the programming. And as always, you can open a Thonny and create a new file. The first step is to import MicroPython modules and classes. From machine, import ADC and pin. We need ADC or analog to digital converter to read the sensor's analog values. And we need pin to activate GPIO 15 to control the on and off signal to the TIP122. From time, import sleep in order to get some delays. And the code is fairly simple and quite similar to other code that we have already seen. So why not give your students some time to figure it out for themselves? So after we have identified the classes, we can now define the sound pin, which is ADC 26, and the motor pin, which is pin number 15, and it is an output pin. And now we start with our while loop, so while true, the sensor value is what we read from the sound pin. So sensor value equals sound pin read underscore U16. And just to check, we will check it in the REPL, we print the sensor value. And just like with the light-dependent resistor, we also have to define a certain threshold value. So once again, this is something that you will need to find out through some experimenting. So let's start with a value of 500. If sensor value is larger than 500, then the motor pin value will be set to 1, and we introduce a delay of 2 seconds. Else, so if that's not the case, else the motor pin value is set to 0 and we set a delay of 5 seconds. Let's give it a try and see if everything is working. Clap in your hands, and yes, we can see that the fan starts and stays on for the time that we defined in the sleep command. Now, one small piece of advice and warning, these sensors are not always the most sensitive ones, so it is quite possible that you have to make a lot of sound and a lot of noise for them to work. So also there, don't be afraid to experiment and to find the best possible values. If it doesn't work for some of your students, do not panic. Really engage with them in some logical fault finding. Were there any error messages in the REPL of Thonny? Did you connect a common ground between the power supply and the Raspberry? Is the 9-volt battery sufficiently charged? Did you select the right Raspberry and the right comms? Did you connect the components to the right GPIOs? Is the sound sensor sensitive enough? Some of them have a pot meter that you can turn in order to increase the sensitivity. Are there any loose wires or legs? Or maybe you're just unlucky and one of the components is broken. That's it for our 4th lesson. I hope you and your class enjoyed it. In our 5th lesson, we are going to capture data from the LM35 temperature sensor and introduce some basic mathematical functions in MicroPython. Looking forward to welcome you again, and bye bye for now.